This video goes over the remainder theorem and the factor theorem. We're going to start actually with example 4, which is the remainder theorem, which states that when a polynomial function is divided by x minus h, the remainder is the polynomial evaluated at h, and if it's divided by ax minus b, the remainder is the polynomial evaluated at b over a. So in my first example here, I'm going to define my polynomial, x cubed, 2x squared, and I'm only asked to find the remainder. So I'm going to identify my divisor, x minus h. That means my h value is just 1, and I'm going to evaluate my polynomial at 1. When I do that, I need to make sure I put in a 1 everywhere I see an x, and then I can evaluate that. This one is simple enough to do in one step using mental math. I would get positive 1. And then this is my remainder. So therefore my remainder is just 1. And I'm going to repeat the same thing on the other side here. So I'm going to define my polynomial, 8x cubed plus 4x squared plus 17. Here, I have an ax minus b form, so I'm going to, when I substitute in, I'm going to use minus 3 over 2, sort of like I'm setting that bracket equal to 0 and solving for x, and then I'm going to substitute in minus 3 over 2 anywhere I see that. Now we are using calculators. This should be something that you are comfortable putting into your calculator and evaluating in one step. Algebraically, you would have the skills to do it using a common denominator, but you should be able to do it in terms of efficiency using your calculator here. So our remainder is 1 for our first example, and our remainder is minus 1 for the second, both of which we found without dividing. So now I'm going to go back to example 1 and the factor theorem. And I told you before that the factor theorem is an extension of the remainder theorem. So ax minus b is a factor if and only if our remainder is equal to 0. So here in our first example, we're going to try and figure out if these two terms are factors of my given polynomial. In order to do that, I'm going to substitute in my 3. I've got 2 times 3 cubed plus 3 times 3 squared minus 3 times 3 minus 2. And then I'm checking to see if this is going to equal 0. In this case, this one does equal 0, which means that x minus 3 is a factor. And then I'm going to repeat the same thing down here for my other binomial. So I'm going to evaluate at p at minus 2. I'm going to substitute in minus 2 anywhere I see an x. And when I evaluate that, I'm going to get 40, which means that x plus 2 is not a factor because the remainder is not equal to 0. So we're going to use this fact to do one example, which is factoring the polynomial. And so the first thing that I need to do is I need to find a factor to test, or I'm looking for my first factor. My factors all have to be factors of my last term in this case. So my possibilities are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And then I'm going to define my polynomial, and then I'm going to start checking to see which one is a factor. So in terms of efficiency, if it's 1 or minus 1, you might be able to do that using mental math. If not, you should be using a calculator because sometimes it takes a long time to find. So when I substitute in 1, I would substitute in 1. You don't necessarily have to write it out, but I'm going to do it so that you can see what I'm doing. This is not equal to 0, so then I'm going to move on to my next factor. I start with minus 1 and 1 because those are small numbers. They're easy for me to work with. So I've got minus 1 cubed plus 2 times minus 1 squared minus 5 times minus 1, minus 1, plus 2, plus 5, and then minus 6, which is equal to 0, which means that x plus 1 is a factor. So that means that I know that I can write my polynomial in terms of x plus 1 times a separate polynomial function. So this is really my first step here, is I'm finding a factor. And then my second step is that I'm going to divide out that factor. And so in order to do that, I'm going to use synthetic division or long division. I'm putting my coefficients in front here, bring down the 1, add my next column here. I'm going to add my next column here. And I should, as long as I have a factor, get 0 here. That means that x squared, x minus 6, is my other polynomial. So now I'm going to write out and factor. So my polynomial, I know, is a result of x plus 1 times x squared plus x minus 6. This second part is a quadratic, which means that I can factor that using what I learned in grade 10, multiplying to the last term and adding to the middle term. So x plus 3 and x minus 2. And now I have my fully factored cubic polynomial.